Hello and welcome everyone. In today's video, we will learn about LangGraph. First, let's understand about LangGraph. LangGraph is a library designed for building resilient, stateful, multi-actor applications using language models. Developed by LangChain Incorporated, it extends the capabilities of LangChain by allowing the creation of graphs that can handle cycles and branching, making it possible to implement complex workflows involving loops, conditionals, and persistent states across multiple steps. LangGraph's ability to manage cycles and stateful interactions makes it a powerful tool for developers looking to create more interactive and intelligent applications using language models. In today's video, we will review how to recreate the canonical LangChain agent executor functionality in LangGraph. The benefits of doing it this way are that it will be much easier to modify parts of it to fit your custom logic. Let's get started. Now, let's create the virtual environment by following this command. Our virtual environment has been created. Now we will activate our virtual environment using this name of the virtual environment /scripts/activate command. After activating the virtual environment, we will create the requirements txt file to write down the required libraries. Now run this command to install all the required libraries. All the required libraries have been installed. For LLM, we will use OpenAI. And for the web search tool for our agent, we will use the Tavily. Now, we will set up our environment variables. These variables include our API keys for OpenAI and LangChain, which we will store securely using a.env file. This ensures our sensitive information stays safe. Create the .env file.
Put your OpenAI_API_ key here.
To get the OpenAI API key, open your browser and type OpenAI API key and sign up. Now click on API keys and click on Create API key. Remember one thing, OpenAI provides only some limited calls using the OpenAI API key. After that, to continue to use the OpenAI API key, you have to purchase a plan OpenAI. Copy the API key and paste it in .env file. Now put your Tavily API key here. To get the Tavily API key, open your browser and type Tavily. Click on the first link. Now click on Get Started. Next, click on Sign In and Log In. Here you will find your Tavily API key. This API key is only valid for 1,000 requests. Copy the API key and paste it into .env file. Create a new file to write the code. First, we will import the necessary libraries. From LangChain, import hub. From LangChain, agents, import create_OpenAI_functions_agent. From LangChain_community.tools, Tavily_search, import Tavily search results. From LangChain_OpenAI chat_models, import chat OpenAI. Import OS .env. .load_.env. LangChain provides the framework, while .env helps manage environment variables securely. The hub, create_OpenAI_functions_agent, and specific tools like Tavily search results and chat OpenAI are essential for building our agent. Next, we will set the API keys for OpenAI and Tavily. These keys are fetched from the environment variables loaded earlier, ensuring that sensitive information is managed securely. OS environ OpenAI_API_key equals OS getenv OpenAI_API_key. OS environ Tavily_API_key equals OS getenv Tavily_API_key. We will configure the Tavily search tool to return a maximum of one result. Then, we will pull a predefined prompt from the LangChain hub. This prompt will guide the agent's responses. Tools equals Tavily search results max_results equals 1. Prompt equals hub.pull watches 17/OpenAI functions agent. Now, we will choose the GPT 3.5 Turbo 1106 model from OpenAI, enabling streaming for real-time responses. This makes interactions more dynamic and responsive. LLM equals chat OpenAI. Model equals GPT 3.5 Turbo 1106. Streaming equals true. Next, we will create the agent using the specified language model. LLM, tools, and prompt. This agent will handle the interactions and provide intelligent responses based on the prompt and tools configured. Agent underscore runnable equals create underscore OpenAI underscore functions underscore agent. LLM, tools, prompt. Next, we will define the agent state class to manage the state of our agent. It includes the input, chat history, agent outcome, and intermediate steps. This structure helps maintain the flow and state of the conversation. To define agent state, we have to import operator, annotated, typedict, union and agent action, agent finish, and base message from LangChain underscore core. Import operator. From typing import annotated, typedict, union. From LangChain underscore core, agents import agent action, agent finish. From LangChain underscore core, messages import base message. Class agent state, typedict. Input, str. Chat underscore history, list, base message. Agent underscore outcome, union, agent action, agent finish, none. Intermediate underscore steps, annotated, list, tuple, agent action, str, operator.add. Now, we will create a tool executor to handle the execution of tools based on agent actions. This executor will take the list of tools and manage their invocation. To create a tool executor, we have to import tool executor from LangGraph. From LangGraph, pre-built, tool underscore executor, import tool executor. Tool underscore executor equals tool executor, tools. We now need to define a few different nodes in our graph. In LangGraph, a node can be either a function or a runnable. There are two main nodes we need for this. The agent node will be responsible for deciding what actions to take. A function to invoke tools. If the agent decides to take an action, this node will then execute that action. Def run underscore agent, data. Agent underscore outcome equals agent underscore runnable. Invoke, data. Return, agent underscore outcome, agent underscore outcome. Def execute underscore tools, data. Agent underscore action equals data, agent underscore outcome. Output equals tool underscore executor. Invoke, agent underscore action. Return, intermediate underscore steps, agent underscore action, str, output. Run underscore agent invokes the agent with the provided data and returns the outcome. Execute underscore tools takes the agent's action, invokes the corresponding tool, and returns the results. Now, we will implement conditional logic with the should underscore continue function. This function will check if the agent's outcome is an agent finish. If it is, it returns, and otherwise, it returns continue. Def should underscore continue, data. If ice instance, data, agent underscore outcome, agent finish. Return end. Else, return continue. Next, we will define a new state graph with the agent state. Two nodes, agent and action, are added, corresponding to running the agent and executing tools. The entry point is set to the agent. We will add conditional edges to control the flow based on the agent's outcome and compile the workflow into a runnable application. First, we have to import state graph. From LangGraph, graph import end, state graph. Workflow equals state graph, agent state. Workflow.add underscore node, agent, run underscore agent. Workflow.add underscore node, action, execute underscore tools. Workflow set underscore entry underscore point, agent. Workflow.add underscore conditional underscore edges, agent. Should underscore continue, action, end end. Workflow.add underscore edge, action, agent. App equals workflow.compile. Finally, we will run the application with initial inputs. The query and chat history will be provided as inputs. The results will stream and print in real time, showcasing the dynamic response capabilities of our agent. Inputs equals input. What is the weather in Noida, India? Chat underscore history. For S and app stream, inputs. Print. List. Est of values 0. Print. Now run the file. Here you can see the results. It is working perfectly. In today's video, we learned about LangGraph and created Agent Executor in LangGraph. I hope you found this video helpful. Thanks for watching, and let's meet again in the next video.